Hello my dear students, it's my pleasure to meet you today again. We are going today inshallah to study a new lesson which is algebraic lesson about solving quadratic equations graphically. We have studied before solving quadratic equations algebraically, and now inshallah we are going to solve it graphically. Okay, concentrate here solving quadratic equations graphically. What is the meaning of solving graphically? If we have an equation like that, a x power 2 plus bx plus c equals 0, okay, and of course a, as we said before, doesn't equal 0, okay, to be quadratic, because quadratic means that the power or the greatest power is 2. Okay, so if we want to graph this quadratic function, we will write it as f of x equals ax power 2 plus bx plus c, and we have an interval, closed interval, d and e as example, and d and e belongs to R. Okay, after that we will graph as x-axis and y-axis like that. Okay, to have a graph x dash, y and y dash, and the graphs will take something like that when we graph it. Say this point is L and this point is M. So the intersection points or intersection numbers with x-axis, the graph here makes intersection points with x-axis as L and M. The solution set will be L and M. Okay, we have to find solution set in R. Okay, what is R? It is the set of real numbers. And also we have two other figures of this representation, as we have three conditions of solving quadratic equations, my dear students. The first one we have right before, and now we are going to deduce the second and third figures. Concentrate with me here. If we have y-axis like that and x-axis like that, this is x dash, y dash, and we have the graph like that. It's parabola. This is the figure of quadratic equation, and we have here just intersect with x-axis with one point, or say this point or this number is L. So solution set here will be L. And also if we have a graph like that, here the graph doesn't intersect x-axis at any point. That means that its solution set in R will be phi, because it doesn't intersect x-axis at any point or any number. Okay, so we have three cases. One of them intersect x-axis at one point like that. Say this number is L and L belongs to R, so solution set equal L. Or sometimes the graph take this figure, say this point is L and this point is M, and we can say this point L and 0, and this point M and 0, okay, as a point, because y here is 0, and solution set here will be, as we said, L and M, and we know L and M belongs to R. Okay, let's take an example here. We will have some examples to graph quadratic functions or quadratic equations. If we have an example like graph the equation x power 2, yes, x power 2 minus 2x minus 3 equals 0. First, we have to find a table. We can, the question is, the interval we use is from -2 to 4. So we will substitute about x by -2, -1 as this one, -2, -1, 0, 1, 2, 3, and 4, and so on. Okay, we start with -2 and we end with 4. So we will have a table like that, x and y. What is x? X here is the number -2 first. When we will substitute about the function of x equal x power 2 minus 2x minus 3, will -2, f -2 equals, we will substitute about x by -2, -2 power 2 minus 2 multiply -2 minus 3, and the answer will be 5. So at x equal -2, the function equals 5. Then we have to find f of -1, -1 power 2 minus 2 multiply -1 minus 3, and the answer will be 0. F of this is -1, y is 0. F of what? F of 0 will be 0 power 2 minus 2 multiplied by 0 minus 3. Of course, it gives -3. So when x equals 0, y equals -3. And also, by substitute about x by 1, it will be 1 power 2 minus 2 multiply 1 minus 3, and the answer equal -4. Okay, by substituting by 2, when x equals 2, 2 power 2 from here, x power 2 means 2 power 2 minus 2 multiplied by 2 minus 3, and the answer will be -3. 3, f of 3 equals 3 power 2 minus 2 times 3 minus 3, and the answer will be 0. The last one, 4, f of 4 will be 4 power 2 minus 4, 2 times 4 minus 3, and the answer will be 5. So we have a table now, x and y. X -2 and y 5 means the point -2 and 5. X -1 and 0, and y is equal 0. So the point -1 and 0, the point 0 -3, the point 1 -4, and so on. Okay. So We have another method by using calculator. If you have a calculator, scientific one, you will be open the calculator and press on the button mode, then table, search about table, have a number, maybe 7, will be find that fx equal. We try to write the function x power 2 minus 2x minus 3 in the table and press equal. After pressing equal, you have a number. First number here is -2. You put -2 and press equal. Then you put 4, the last number, and press equal. Then you will find this table. You will find this table and just to graph it. Okay. We will graph the table now, but we have to first draw x-axis and y-axis like that. We'll draw. This is y-axis and this is x-axis now. Y dash. Okay, and we have numbers here: 1, 2, 3, 4, 5, 6, and so on. -1, -2, -3, and so on. -4 also. 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6. The first we have the table here. The first point is -2 and 5. -2 and 5 means this point. -1 and 0. -1 and 0 is this point because the first is -1 and the other is 0. 0 and -3, this point. 1 and -4, 1 here and -4 here. 2 and -3, 2 and -3. 3 and 0, this point. 4 and 5, 4 and 5. Okay, then we will graph using hand. Okay, we here have the graph. This number is -1 and this number is 3. We notice that the graph here intersect x-axis at 2 points, this point and this point. The value of x here is -1 and the value of x here is 3. So we can say that solution set here equals -1 and 3. And now we graphed the function x power 2 minus 2x minus 3, and we solved the equation x power 2 minus x minus 3 equals 0. Its solution set is there, is this number. What is the meaning of the solution set equal -1 and 3? If we substitute here x power 2 by -1, the left hand side here will be definitely equal 0. Let's look at it. -1 power 2 minus 2 multiplied by negative 1 minus 3, of course, equals 0. So it's satisfied solution equal negative 3. And the next one, what about 3? If we substitute about x here with 3, 3 power 2 minus 2 times 3 minus 3, the answer, of course, equals 0 also. Okay? That means that the solution set is equal negative 1 and 3. That means the negative 1 here satisfies this equation, makes the left hand side equal right hand side, which is 0. And also 3 makes the left hand side equal the right hand side, which is 0. Okay? Let's move to another equation. What about another equation? Let the equation to be negative x power 2 minus 4x minus 4 equals 0. That means that the function is negative x power 2 minus 4x minus 4. And the interval that we use will be from negative 5 to 1. Okay, as we said, you can use your calculator. It's easy for you. Press mode. Then you will find the word table. Table have a number. If you have scientific one, will be 7. The table sometimes be 7, and we will find that if x equal, and you have to press alphabetical first and x, and press power 2. Okay, this function will be negative here, negative x power 2 here, and the negative 4. Then press alphabetical, then x, then negative 4. Okay, and you will press negative 5, then press equal, then you press 1. Then you will have the table. This table will be like that, x and y. Okay, negative 5. Okay, complete. Here, negative 5 for x will gives negative 9. Negative 4 will gives negative 4. Negative 3 will gives negative 1. Negative 2 will give 0. Negative 1 will gives negative 1. 0 will gives negative 4. And finally 1 will give 9. Okay, we have now complete the table. It remains to draw the table. Before you draw, you have to look at the numbers. The numbers of x-axis will be the greatest number and negative number will be negative 5, and positive number will be 1. Okay, and here y-axis, the smallest number negative 9 from left down, and greatest one is 9. So we will graph that y-axis. Okay, and x-axis here. This is x-axis and this is y-axis. Okay. Here we can say 2, 4, 8, 10. Negative 2, negative 4, negative 6, negative 8, and negative 10. Here 2, 4, 6 also, 8 and 10. I must use two numbers because I have little area here. Here we have 1, 2, negative 1, negative 2, negative 3, negative 4, and negative 5. Okay, and we will find out the points negative 5 and negative 9 here, negative 5 here, and negative 9 here, like that. Negative 4 and negative 4 here, negative 4 and negative 4 will be here. Negative 3 and negative 1, negative 2 and 0, negative 1 and negative 1, 0 and negative 4, 1 and 9, and the drawing will be something like that. Okay, this is a curve, it's upside down curve. Okay, here we have just one point intersecting between the curve and x-axis. This point will be negative 2 here, here negative 2 and 0, and the solution set here will be negative 2 only. Okay, and notice that it's down curve, and look here, a here, the coefficient of x power 2 is negative. So take it as a rule, if the coefficient of x power 2 is negative, it will be down graph. Okay, if we have here negative x power 2, negative real number x power 2, and the coefficient is negative, then it will be down. But if it is positive, the curve will be up. Okay, let's move to another example. We have many examples for you to understand well how to graph and how to find graphically the solution set of the equation. We have here a function fx equals x power 2 plus 2. Okay, and solution set of x power 2 plus 2 equals 0. Okay, and we have the interval from negative 3 to 3. We will remember again, you can use calculator or you can use direct substitution, and in the two methods you will be here a table like that. This is x, this is y. Here we will start with negative 3. At negative 3 you will find y equals L equals 11, negative 2 6, negative 1 3, 0 2, 1 3, 2 6, and finally 3 11. And the remains to find the figure or to draw the graph. we will have the numbers of x-axis here. The smallest number from the left equal -3, the right number is 3. So we have no problem about x-axis. But y-axis here is 11. All of them are positive. Okay. And here is 11 is the greatest number of y. So we need to start from this part to have great y. This is x-axis and this is y-axis. You have a notebook graph, so it will be more easier for you than me. We have here x dash, y and y dash. Here the numbers of x will be 1, 2, 3, -1, -2, -3, and here we can say 2, 4, 6, 8, 10, 12, and we will draw the points -3 and 11. Here -3 and 11. 11 is here in the middle between 10 and 12. You can use the ruler. Okay. This is the point. -2 and 6. -2 and 6 will be this point. -1 and 3 will be this point. 0 and 2, 0 and 2 here will be this point. 1 and 3, 1 and 3, 2 and 6, like that. 3 and 11, 3 and 11, just in the middle between 10 and 12, and we will graph using hands. We have this graph now, and look carefully for here is +1, the coefficient of x-axis or x power 2 here is positive, so it's forward or up. The graph is up. And if it is negative, the coefficient of x power 2 negative will be down. Okay? We have here solution set. We have two intersecting with x-axis. So solution set in R or in real number here equals phi. Phi is empty set. That means that if the curve up or even down and it doesn't intersect or it doesn't intersect with x-axis, so the solution set here equals phi. And from this point, let's move to another set of numbers. Now, my dear students, we have to study new set of numbers. What is the new set of numbers here? We have studied before how to solve equations in many set of numbers. If we have an equation like that, and he asked me to solve in n, we know the set of n equals 0, natural numbers, 0, 1, 2, and so on. The first example is we have here an equation like that. If we have x plus 5 equals 2, we will solve the equation as x equals 2 minus 5. So x will be -3. and he asked me to solve in n. N is natural numbers, but we have here x equal negative 3, and negative 3 doesn't exist in the natural numbers. So solution set here in n in natural numbers equals 5. So we needed to extend to another set of numbers, which is z. Z here, 0 in the middle. We have 1, 2, and so on. Negative 1, negative 2, and so on. That means that we have here negative 2 and negative 3. So if you ask me to solve this equation, which is x plus 5 equal to in z, the solution set will be, of course, solution set will be negative 3. Why here is negative 3 but there is 5? Because negative 3 exists here in the integer numbers but doesn't exist in natural numbers. And if he asked me to solve this equation to x equals 1 in z, is it has a solution in z? Let's move. We have to divide by 2 in the two sides to solve this equation. So x here will be half. And ask yourself, is half here exist in z? It's no. So we have extend to q. Q is a set, means any number can put in this figure a over b, and a and b belongs to z, and b of course doesn't equal 0. Okay, so any fraction or decimal belongs to q. So half belongs to q. So if you ask me solve in q, the solution set here will be half. But in z will be 5 because half doesn't exist in z, and so on until we have q dash. Q dash number is as example pi, which is approximately 22 over 7, not exactly but approximately, and also square root 5, cubic root 10 as example, and so on. These numbers pi, root 5, and cubic root 10 and so on doesn't exist in q, but they are belongs to q dash. Okay, so if we have equation like that, x power 2 equals 7, so x will be equal positive or negative square root 7. Solution set of this equation, solution set in q is 5, but in q dash will be square root 7 and negative square root 7. Okay, so we will extend to real numbers. We have to concentrate about numbers, my dear students. We have many sets of numbers we have studied before. As example, we have here natural numbers, which is 0, 1, 2, 3, and so on, and we extend it to z numbers. Z numbers includes 0, 1, 2, and so on, and we add to them negatives, negative 1, negative 2, and so on, and also extend these numbers to be q. These numbers, all of them belongs to q, but also we add half, as example 3 over 5, 0.9, and so on. and we extend to another set of numbers, which is q dash. Q dash here will be square root 5, cubic root 9, and pi as example, and so on. These numbers, all of them, q union q dash, all of them is R, which is the set of real numbers. If we have an example like that, if you ask it to solve this equation, x power 2 equals -1, so x equal positive or negative square root -1, you will be find a big problem here to solve in R. So solution set in R here equal phi, because we haven't a real number equal square root -1, but we must extend to another numbers or set of numbers called C. C here is the set of complex numbers, okay, and set of complex numbers here is any number can put in the figure a plus bi, a and b reals. We can say that a is real part and bi is imaginary part, okay, and b of course doesn't equal 0, or even if it is 0, then it will be real number. So we have a big set of number, bigger one here, called C, and C, my dear students, here includes all these numbers, but also any number can take the figure a plus bi. A plus bi as example 2 plus 3i. But what is I? We will study more about I now. I is called the imaginary number, and we will define it carefully, so concentrate with me. We have to solve the equation x power 2 equals -1, but in fact its solution in R equals phi, because square root -1 doesn't belong to R. So the mathematician talk about definition, new definition, which is -1 here is I power 2. I power 2 equal -1. So when we substitute by I power 2 instead of -1, the equation will be like that. X power 2 equals I power 2. And by taking square root for the two sides, x will be positive or negative square root I power 2. And also x will be equal positive or negative I. So solution set here will be I and negative I. You will ask me, what is I? We said about the complex numbers a plus bi. Here a is 0, b is 1, so it's 1i. So the first solution is 1i, and second one is -1i. But we don't write 1 or -1, so it's I and negative I. Okay, let's move to how is I again, and some figures of I, which is the imaginary number, imaginary number, which is I. We said that I is I, and I power 2, it's negative 1 from definition. Then what about I power 3? I power 3 will be I multiplied by I power 2, of course. And I multiplied by I power 2 equals negative 1, so it's equal negative I. What about I power 4? I power 4 here, it's I power 2 multiplied by I power 2. So it's negative 1 multiplied negative 1. So it's 1. So we can conclude these figures or these shapes of I in this box. We have I itself. We have I power 2 equals negative 1. We have I power 3 equals negative I, like that. We have I power 4 equals 1. Keep it well. We have I power 2 from definition equals negative 1. I power 3 equals negative I, and I power 4 equals 1. Okay? And we will complete about I and imaginary numbers next time, but let's start now to solve another equation graphically. If he asks me about this equation, solve in R, 4x multiplied by x minus 1 equals 0, and verify it algebraically. Solve it graphically here. And in fact, he didn't give me any interval. First, we have this figure for the quadratic equation here. It is not the usual, and to have the usual or the formula of the quadratic equation, we have to multiply it by 4x by x minus 1. 4x times x will be 4x power 2. 4x times 1 will be 4x. So it's equal 0. If you want to, sorry, here is negative 5. So here negative 5 equals 0. And if you want to solve it algebraically, we know about the formula. Do you remember, my dear students? The formula x equal negative b plus or minus square root b power 2 minus 4 ax ac over 2a. And we ask ourselves, what is a, b, and c? A here is 4, b is negative 5, negative 4, sorry, and c is negative 5. And by direct substitution here, x will be negative b here is 4 plus or minus square root b power 2 means negative 4 power 2 minus 4 times a is 4, c is negative 5, and all of them over 2 times a, which is 2 times 4. And x here will be approximately equals approximately 1 plus or minus square root 6 over 2. This might mean that 1 plus root 6 over 2, and the other solution will be 1 minus root 6 over 2. And this number approximately equals 1.7, and this number approximately equal negative 0.7. This is algebraically solution, because you asked me to verify algebraically. Okay, we will return about solution graphically here. solve again this equation, which is x power 2 4x power 2 minus 4x minus 5 equals 0 graphically, but he didn't give us interval. So we have to find a solution. Remember well about the vertex point of the graph. The vertex point, we will take it by the rule negative b over 2a and f of negative b over 2a. What is this? We know that 4 is a, negative 4 is b, and c equals 5 here. And we will find the number negative b over a first. Negative b over 2a equals, negative b means 4, the converse of the sign, 2 multiplied by a, which is 4. So it's half. So negative b here over 2a equals half. And we will substitute about half here to find the function. F of half equals here 4 multiplied by half power 2 minus 4 times half minus 5, and the answer will be negative 6. So we have vertex point here of the curve is half and negative 6. Look carefully, my dear students. We have an equation and its function, we can call it 4x power 2 minus 4x minus 5, and we have no interval. Okay. So when we have x-axis and y-axis here, and you have here x-axis and y-axis like that, and you will take this table, or you will create this table using algebraic method, or you can use calculator. And what the numbers we put here, x is half, and the vertex point here is half and negative 6 here, half and negative 6. Half here for x, we can put here 0 and negative 1, here 1 and 2, and complete this table. You will find that negative 2, its y equals 3, here negative 5, negative 6, negative 5, and 3. And you will find that this curve will take this figure. Here is 2, here is 1, and here is negative 1. And solution set here, the intersection point with x-axis, which is here negative 0.7, and here approximately 1.7. So solution set equals negative 0.7 and 1.7. Okay, my dear students, I'm pleasure to meet you today, and the next time, inshallah, we are going to study new lesson about trig lessons. Goodbye and good luck.